Okay, hope everybody is doing all right today. We're quickly winding down this semester. Next Friday is, of course, the end. I won't see you next Thursday, but I will see you first thing next Friday morning, because that's going to be 5 through 8. We'll take our finals. So we should pretty much wrap up everything I want to discuss when it comes to inverses today. Tomorrow we'll come in. I'll have a little in-class assignment for us to work on. I kind of did one differently than what I had originally thought. But tomorrow, while we're working on that, I'm going to call you up one at a time. I'm going to help you determine what your semester average is, and that'll tell you how important the finals are going to be to you. Everybody, has to take the finals, so if you don't do well or you're still going to pass, I think a lot of people will. I think there's only a few people who the final is really going to determine what your semester grade is. But you'll get the assignment tomorrow. We'll take care of the semester averages tomorrow. I won't be here Friday. If you'll remember, I'll be grading a bunch of essays, so it's going to be super fun. But the substitute is also going to pass out the final reviews on that day. So you'll have that assignment you can look at. You can look at the review, one of the two. Next week we'll have our district assessment. We'll take care of that Monday and probably Tuesday. And then whatever is left, like Tuesday and Wednesday, we'll talk about the review. Okay. And I'm taking questions right off the review, and that is going to be your final. So if you feel good on the review, you should be good to go on that final. And the only other thing I want to mention, I put it up here so I wouldn't forget, because I'm not going to be in the class on Friday, there won't be any tutorials on Friday morning. So if you are wanting to retake the test from last week, that is, the deadline's Monday morning. Okay, so that'll take care of that. All right. Well, let's go ahead and get started. We've been talking about inverse trig function. There's only one left, and even though it's tangent, there's really not a whole lot left to talk about. I want to just kind of show you a bunch of examples. Well, here's what we know so far. Okay, let me go ahead and get a couple of circles here. Let's say another one here. Okay, so let's say we're dealing with cosine inverse and sine inverse. Now, for sine inverse, remember, sine inverse is going to be restricted to the right side of your unit circle. So you're always going to find sine inverse in quadrants, what? 1 and 4. That's the right side of your unit circle, right? Now, cosine inverse, we started looking at him yesterday. He's going to be restricted to the top half. So he's going to be in what quadrants? 1 and 2. There we go. So let's go ahead and write this out real fast. So sine inverse, okay. Remember, we go ahead and plug in a ratio, and we're going to get an angle measure out of this. Same thing for cosine inverse. We're going to plug in a ratio, and we're going to get an angle measure out of this. Okay, but the thing about the inverses, they're very particular about what ratios they will take and what angle answers they'll give. If it's sine inverse, the ratio has to be between -1 and 1. And then your answer is going to have to be between -pi/2 to pi/2. And you'll notice from -pi/2 to pi/2, that is the right side of the unit circle. That's quadrants 1 and 4, what we just said. For cosine inverse, the input ratio has to be the same. It has to fit between -1 and 1. Okay? If whatever I'm plugging into the inverse is not between -1 and 1, well, it's not going to work. Okay, I can actually show you that in just a second. But the answers for cosine inverse are just a little different. Those answers have to be found between 0 and pi. Again, you'll notice here's 0, here's pi. So that's why cosine inverse is restricted to quadrants 1 and 2. In fact, give me a number that's not between -1 and 1. 7. Okay, so if I came on over here to the calculator and I said, okay, I want to evaluate cosine inverse of 7. And see, we already know there's going to be a problem because 7 is not between -1 and 1. So if I push enter, see, it says, okay, there's a problem here. You're not going to be able to get an answer. But as long as your ratio is between -1 and 1, you're going to be able to get an angle measure. Okay. Now, I believe we were looking at some examples of these. Okay. We finished up with B. I don't think we got to C just yet, did we? Yeah, I think we just finished up B. Is that right?
Yes.
Okay. Well, let's take a look at C. Now, one other thing I just want to go ahead and talk about very quickly are just those triangles, the special right triangles. Now, here we have the 45, 45, 90 and the 30, 60, 90. Now, let's do everything in terms of X. Okay. Now, the legs on a 45, 45, 90, those are always X units long, right? But how do I find the hypotenuse using a leg? X square root of 2. You just multiply the leg times the square root of 2. Perfect. Now, in a 30, 60, 90, the shorter leg across from 30 is always X. Well, how do I use that leg to find the longer leg? What's across from 60? Oh, that's the other one. Not times 2. There you go. If you multiply the shorter leg times the square root of 3, that's going to be the longer of the two legs. If you take the shorter leg and double it, that's going to be the hypotenuse. So we're looking for these relationships here. Now, if there's not one of these special right triangles, well, that's when we get out the protractor and we go ahead and measure the side lengths that we're given. Okay, so let's get to an example. I think we're currently on this one right here, C. So we're still on cosine inverse. Okay, so we have the square root of 2 over 2. Now, the first thing you got to figure out, what quadrant would we be in? Would this be in 1 or 2? What do you think? Okay, I heard 1. Why are we saying 1? What's wrong with 2? There you go. Remember, cosine represents the x value, right? So x is positive in the first quadrant, but it's negative in the second. That's how you decide the quadrant, a sign of your ratio. Okay, so I know this guy's got to go in quadrant 1. So let me pull this over a little bit so I have some more room. So I'm going to draw my terminal side. Doesn't matter where I put it as long as it's in the quadrant. Now I'm always going to connect it to the x-axis. This is what I'm looking for, that angle. We always start rotating from standard position, the positive x-axis. Well, let's see. What ratio is cosine? It's always what over what? It's always the x opposite. Okay. Now, would you like me to do it in terms of the variables or like opposite hypotenuse in that? The variables? Okay. So cosine is always x over the radius, right? So this would be the square root of 2. This would be 2. Now, is everybody okay with how I'm starting to fill in the triangle? Okay. So how am I going to find that missing side y? Okay. Now, you're absolutely right. Okay. Antonio's already recognizing what it is, but let's say some people don't recognize just yet. Let's use the Pythagorean theorem. So I'm going to take the y squared plus the square root of 2 squared is equal to the hypotenuse squared. What happens when you square a square root? Okay, it cancels, so that's just 2 is equal to 2 squared 4. Okay, now I would subtract the 2. Those cancel, so y squared equals 2. And how do I get y? Square root. Okay. So that height here, the missing side, is the square root of 2. So is this one of my special right triangles? Is Antonio right? Yeah, in fact, which is it? How do we know it's 45? What immediately tells me that? The two legs turned out to be exactly the same. So I know that has to be 45 degrees. So the answer to this would be 45. Now, what if I wanted to put it in radians? What's 45 degrees as a radian? Pi over what? 4. That is exactly right. That's it. That's what we're looking for. We're given the ratio. We want to know the angle measured. Okay. All right. Well, let's go ahead and try another one of these. Now, let's go back to A. I'd skipped it previously because there was something unique about it. Okay, so it says cosine inverse of 0, right? Well, what quadrant would I put this in? Would it be in the first or the second? And see, this one's, yeah, there you go. Okay, Angel's already figured it out. This one's a little different because 0 is neither positive nor negative, right? Well, let's say you just go ahead and put it in quadrant 1. Let's say we just try to draw a triangle. Okay, so here's the theta that I'm looking for. Now remember, 0 is the same as 0 over 1. And we just said that cosine is x over r, right? Well, if I go ahead and plug these in, that would be 0. This would be 1. But do you already see a problem? We can't create a triangle because one of the sides is 0. Now, this will happen from time to time, okay? And Angel's absolutely right. If a triangle has a side that's a length of 0, meaning we can't have a triangle, it has to be a quadrantal, okay? What does that mean, it has to be a quadrantal? There you go. It has to be on one of the axes, right? So let me pull up a circle here. This will represent the unit circle. Now, where is cosine inverse restricted? Okay, so I'm going to put my axes right here. So that'd be the origin. Was cosine inverse restricted to 1 and 4 or 1 and 2? 1 and 2. So in the area that he's restricted, there are 3 possibilities. We have 3 quadrantals there. So this one would be -1, 0. This one would be 0, 1. And this one right here would be 1, 0. Now remember, cosine is x, right? If it comes down to a quadrantal, look at those available and say, okay, which of these has an x value of 0? Which one is it? It's the top one. So how far would I rotate to get there? Oh, 45? 90 degrees. So 90 degrees would be the answer. Now what if I wanted that in radians? Pi over 2. There you go. And that's important. If a triangle falls apart because you have one length of 0, that tells you immediately it has to be a quadrantal. Okay. All right. Did we do D? Okay, let's take a look at D. Cosine inverse of 1/3. All right. So what quadrant will I put it in? Would it be 1 or 2? Why 1? What's wrong with 2? There you go. If it's positive, it's 1. If it's negative, it's 2 with cosine inverse. Okay, so just like before, I'm going to draw a terminal side. Always connect it to the x-axis. So here's the angle I'm looking for. Okay, now we said cosine was always x over r. So this is 1, and this would be 3, right? Okay. Well, now I want to go ahead and figure out what that missing side is. So what am I going to do? Pythagorean theorem. Can anybody set up the equation for me? So it is a squared plus b squared equals c squared. So y squared plus 1 squared equals 3 squared. Okay, what's 1 squared? So y squared plus 1 equals 9. Now we'll subtract the 1. Y squared is equal to 8. So that height would have to be the square root of 8. Okay. And then we could simplify that. You know, we talked about that yesterday. But now, very important question. Is that a special right triangle? Well, why is it not 45, 45? Yeah, the 2 legs would have to be exactly the same. 1 and square root of 8 are completely different. Well, why couldn't it be 30, 60, 90? Yeah, for 1, 3 isn't double 1. Okay, it's more than double. So we can't just immediately say, okay, theta is 45, 30, or 60. So this is where we're going to go ahead and measure this. Okay. So let's come on over here to what we were doing yesterday. Didn't erase that particular problem, and that's okay. Let me get this back to where it was. All right. Let's get rid of that. Delete. I want to get rid of it. There we go. Okay. So we want to go ahead and recreate this triangle. Let me go ahead and draw just a quick one. We have a triangle in the first quadrant where the base was 1, hypotenuse 3, and then we got the height is square root of 8, right? Well, we're going to have to measure it out, so really we have 2 choices. We have centimeters and inches. I prefer centimeters. That way it won't take up a whole bunch of space on your paper. But if you want to use that, you're more than welcome to. Now, we're going to be able to get the 1 centimeter really easy, but that square root of 8, we're going to have to approximate it. How did we do this yesterday? Like the square root of 8 So I know I'm looking for about 2.8 centimeters. Okay. Well, what did we do yesterday to help me get exactly that 0.8? We converted it to something. What's that? Millimeters. Okay. So how many millimeters are there in 1 centimeter? There were 10, right? So if I have my centimeter, my value length, and I just want the millimeters, all you got to do is multiply that by 10. So I'm looking for about 28.3 millimeters. Okay. So this one here, I want the base to be 10 millimeters, and I want the height to be about 28.3 millimeters. Now, hopefully the radius is going to come out to about 30 millimeters, but we don't have to measure it. Okay. So let me bring this guy down a little bit. And let's see what we have. So, all right, I'm going to use my centimeter right here. Now, you notice I'm not putting the edge of my ruler right on my axis because it doesn't start measuring until that first notch. So I'm going to go ahead and put him just like that. So let's say this is my 1 centimeter. That is 10 millimeters. Now, from that point, I want to measure up the 28.3. Okay. So I'm going to do this. Click. Okay. And then again, same thing. I'm going to put it right there. Okay. So let's go up about 28.3, maybe about right there. Would you guys agree? 10, 20, 25, 26, 28. Okay. All right. Now, you can go ahead and draw the sides of your triangle if you want. All we really need to do now is just connect my origin through that point. Oh, and I think I already messed up. Here. There we go. Let me try that one more time. So let's go straight through there. And I always like to draw it a little further than what I have, just so I can make sure it's touching the protractor. And now, what do I do with the protractor? How do I line it up? There you go. This right here, now mine has crosshairs that I'm going to line up with the origin. Some of yours may have an open circle, something like that. But I'm going to place it right on top here. And let's see, I'm going to use my inside track. Okay, so rotating from here over, how far do you think we went? Okay, I heard a few people will say 70. Would you guys agree? Okay, so let's say about 70 degrees. Now let's see how well we did. If I'm going to come over here to the calculator, cosine inverse, we were looking at 1 divided by 3. 70.5. There you go. Now, the way I'm grading these, if you're measuring it by hand, we're going to leave it in degrees. We're not going to worry about changing it. Okay? But I'll go ahead and give you a leeway of about 5 degrees above and below, just in case your measurements are a little off. Okay. But see, even without the calculator, we are able to get the answer we're looking for. So given these side lengths, the 1 and the 3, those are my ratios, I should be getting an angle about 70.5 degrees. Okay. All right, good. How are we doing? Is anybody confused by the measuring? Okay. Would you say that's something that absolutely rules? It rules, ruler, measurement. You'll laugh later. Okay, good. All right. Back to what we were doing. Okay. And then here's our last one, tangent. Okay. So I think I'll just go ahead and kind of get everything in a nutshell for you here, just like I did sine inverse and cosine inverse. Let's say we have a circle. Okay. And if you want me to give you time to fill that in, you're more than welcome to. Just let me know. But we're going to do the same thing, tangent inverse. We plug in a ratio, okay, and we're going to get out an angle measure. Now, tangent inverse is very, very much related to sine inverse. They're both restricted to quadrants 1 and 4. Okay, so just like sine inverse, tangent inverse can only be found in quadrants 1 or 4. So you do the same thing. You choose which quadrant based on sign, positive or negative, draw your triangle, and hope for a special right triangle. Now, his restrictions are a little different. Okay. Whatever you want to plug into tangent inverse, there's no limit on that. Any real number you could possibly think of, you can plug into tangent inverse. There's no limit like cosine inverse and sine inverse. Okay? But there is a limit on the answers I'm going to get. For the angles, it has to be between negative pi over 2 and pi over 2. But here's the difference between sine inverse and tangent inverse. Sine inverse can include those boundaries. Tangent inverse cannot include negative pi over 2 and pi over 2. Okay? So kind of think about being an open circle right there. We're restricted to 1 and 4, but we can't include those values. So if I actually did try to plug in tangent inverse of some number, it's only going to be in that restricted interval. Okay. Did anybody want to take the time to actually copy that down, or do you just want to get to some examples? Anybody want to write that? You did? Okay. Let me give you a minute or so. And while you're writing them down, I just kind of like to think about all the people who like support the way I'm teaching, like farmers, for instance. Okay, they're very pro-tractor. Pro-tractor. Yeah. And this is just showing you how we get those restrictions. In fact, what we just wrote out, is everybody about ready? Yeah. Okay. You see these guys right here, okay? The all reals, and then the negative pi over 2, pi over 2. And then what we did here, kind of summarizing with those intervals, okay? If you go all the way back to the first page, those are the exact intervals that you were given on day 1. Okay? So you may not have an exact idea where the intervals are coming from, but we know they're restricted for the inverse functions. Okay. So let's try some tangent problems. Okay. All right. I'm going to go ahead and skip around a little bit. Let's start with B first. Okay. Tangent inverse of the negative square root of 3. Okay. Now remember, tangent inverse, you can only find him in quadrant 1 or in quadrant 4. So what quadrant would B find himself in? Why 4? Because it's negative. There you go. So I've got a little coordinate system here. So I'm going to draw my terminal side. We know it's in quadrant 4. I always connect it to the x-axis. Now, just like sine, if it's in quadrant 4, that means my answer has to be what? It's got to be negative. Because remember, you always rotate clockwise to get into that quadrant when you're dealing with inverses. Okay. So we don't want to forget that negative. So let's see here. How can I turn negative square root of 3 into a fraction? I can just put it over what? Over what? You can turn anything into a fraction just by putting it over 1. Now, what is tangent's ratio? It's always adjacent over, or not adjacent, sorry. What over adjacent? Opposite over adjacent. I'm sorry, I got confused myself. So the opposite y over the adjacent x. So it's always y over x, right? So across from this theta, that's the square root of 3. The adjacent's the 1, okay? And the square root of 3 would have to have the negative, right? Okay. Well, let's go ahead and find the radius, because we want to see if it's a special right triangle. Okay. Well, what would I use? I know it's a squared plus b squared equals c squared, but what's a and b in this case? It's the negative square root of 3 and 1. Those legs are always a and b. So that would be 1 squared plus the negative square root of 3 squared is equal to the radius squared. Well, 1 squared is what? 1 plus, that would just be 3, because the square root would cancel, and the negative times negative will give me a positive, is equal to r squared. So 1 plus 3 is 4. Take the square root. So the radius has to be what? 2. There you go. And here's my question. Is this a special right triangle? So I'm hearing a lot of yeses, and Nathan says no. Well, let's see. Is the hypotenuse double the shorter side? Yes. Is the longer leg simply the shorter leg times the square root of 3? But that one's negative.
That just tells you.
There you go. The negative just tells you direction. When you're identifying the triangle, don't worry about that. So this one is a 30, 60, 90. The only question is, what's that angle? Is it 30 or 60? It would have to be 60, because 30 is always across from the shorter side. So my answer is 60. Oh, there we go. Remember, we said before, our answer has to be negative because we're in the 4th quadrant. Now, again, let's say I wanted to put that in radians. What's 60 in radians? It was pi over what? It's either 6 or 3. It's 3. Okay, so this would be negative pi over 3 radians. Okay. Now let's go back to A, and then we'll do C, because C is kind of unusual. I just wanted to do B first. I liked it. Okay. All right. So let's take a look at A. Tangent inverse of 1. Tangent inverse, you got to find him in 1 or 4. Jalen, what do you think? What quadrant is he in? 1 or 4? Okay, 4? Close. Now, why would he be in 1, but B was in 4? There you go. Look at the sign. Because this is a positive number, it's got to be in quadrant 1. See, in B, we were in quadrant 4 because it was negative. Okay, so now I know I'm in quadrant 1. We're working A right now. Connect it to the x-axis, just like we always do. Well, how would I turn 1 into a fraction? Yeah, so 1 over 1, right? And remember, we said that tangent is always opposite over adjacent. So that's y over x. So I know this is 1. I know this is 1. Let's go ahead and figure out what the radius is. Okay. So what would be my equation for that? Okay, so Lilybell said 1 squared plus 1 squared equals r squared. Okay. So 1 plus 1 equals r squared. 2 is equal to r squared. And how do I get r from r squared? Take the square root. In fact, did you hear about that new pirate movie they're coming out with? It's rated R. It was good, yeah. I think I really hooked you with that one because it's a pirate joke. Okay, so it is the square root of 2. And here's my question. Is it a special right triangle? Well, which one? Now, what tells me immediately is 45, 45? There you go. The 2 legs are identical. And if I take one of the legs, if I multiply it by the square root of 2, that immediately gives me the hypotenuse. And there we go. So this answer is 45 degrees, or what would that be as a radian? Pi over 4. Remember, 60 is pi over 3, 30 is pi over 6, 45 is pi over 4. Okay. And see, if it's a special right triangle, do we need the protractor? Nope, you only need to measure if it's not a special right triangle. Okay. Well, let's see. Let's do one more. Tangent inverse of 0. Okay. Well, this one is kind of looking odd. 0 isn't positive or negative, so let's just draw a triangle. Okay. I'm just going to say he's in quadrant 1. All right. Well, how do I make 0 into a fraction? Yeah. So that's the same as 0 over 1, right? So that's y over x. So x is 1, y is 0. But do we notice anything? There you go. Can I have a figure? Caught it. Can I have a figure where a side length is 0? No, we actually saw this just a little while ago. If the triangle doesn't work, that means it has to be a quadrantal. Okay. So this one has to be a quadrantal. So now let's get a circle on here. Okay. All right. Now remember, what two quadrants will sine inverse be restricted to? Restricted to 1 and 4, right? Now, for those quadrants, remember there are 3 quadrantals. But this one is actually really nice to us because do you remember, were there 2 of them that didn't work for tangent inverse? Remember, the answers for tangent inverse, answers have to be between negative pi over 2 and pi over 2, right? But we don't include them. So I can't use that quadrantal. I can't use that quadrantal. In fact, there's only one left. What's the ordered pair at that quadrantal? Remember, it was 1, 0. And tangent is always y over x, right? So will this y divided by this x give me 0? Yeah. So tangent of 0 has to be 0. If it's a quadrantal, you have to look at the ordered pair and the measurement to get there. But for tangent inverse, you can't include those two. Pi over 2 and negative pi over 2, tangent is undefined at those. That's why we can't include them. Okay. All right. Let's try another one. Tangent inverse of 5. Okay. Adolfo, what do you think? Quadrant 1 or quadrant 4? Ooh, not 4. Why 1? Because the 5 is what? Positive. Okay. Always look at the sign, and that'll tell you what quadrant you're going to be in. Okay. So this one's quadrant 1. I'm going to draw a triangle. Okay. This is the angle I'm looking for, theta right here. Now, how can I make 5 into a fraction? 5 over 1. And we've already seen several times, tangent is y over x. So the opposite 5, the adjacent 1. Okay. And let me ask you a question. Is this one of the cases where I need to use the Pythagorean theorem? Okay. All right. So let's look for R. Arg. I'm still on about that. Whoa. Whoa. Okay, there we go. I got rid of it. Okay, so somebody give me the equation for this triangle using the Pythagorean theorem. Okay, so it's 1 squared plus 5 squared equals r squared. All right, and 1 squared is 1 plus 5 squared, 25, is equal to the radius squared. 26 equals r squared. So I would say the square root of 26 is going to be my hypotenuse, right? Okay. Is it a 45, 45? No. Okay, so 1 and 5 do not match up. Is it a 30, 60? No. Like 1, square root of 26, is that exactly double 1? No. Okay. So what do I do if it's not one of those special triangles? Got to use the protractor to measure it out. But this one's going to be a lot easier because you'll notice we don't have to convert either of them. We can easily find 1 and 5 centimeters on our protractor or ruler, depending on what we're using. Okay, so let's go back over here. Let me get rid of this. This is the previous problem that we were working on. Okay, so we want to recreate this triangle right here. We just found him to be 1 by 5 centimeters and then square root of 26. Okay, so let me pull this down just a little bit to make sure I can get the 5 centimeters. That is not disappearing for some reason. So we get rid of that. Okay, that's part of it. All right, so, oops. Let me go ahead and get the, got the wrong one there. I want centimeters. So just like before, I'm going to line up. Let's mark 1 centimeter. Okay, let's say right there. And then from there, I want to go up 5 centimeters. Make sure to get, there we go. So let's say 5 centimeters would be right there. Would you guys agree? So 1 by 5. Okay. So let me get rid of this. So now starting from the origin, I'm going to go ahead and draw a line right through that point that I made. Okay. And then now I'm going to go ahead and take my protractor. I'm going to put it right on top. Crosshairs on the origin. Okay. So 1 by 5. Okay, so what would you say? It's definitely in the 70s, but 70 what? 79? Okay. Lilybell says 79. Does that look about right to you? Okay. So starting here, all the way until I hit that line. So we're saying about 79 degrees, right? Well, let's see. Let's come on over here. Let me document B out of this. Tangent inverse. Okay. We were just plugging in 5. 78.6. Perfect. We were pretty much right on. Okay. How we doing? Anybody having any trouble? Okay. Now, this is exactly what your paper is going to be tomorrow. I'm just going to give you some sine inverse, cosine inverse, tangent inverse. Okay. The vast majority of them will come out to be special right triangles, and then 2 of them you'll have to measure. Okay, so it shouldn't be too bad. All right, thank you guys. Let's